Hi, Marty Dwyer with Boat Anchor Audio. We're working on several projects in the lab here, and we decided to use something other than the traditional breadboard. I imagine everybody listening to this has a breadboard or two or three scrolled away. We decided to make up a printed circuit board that could be used for developmental, experimental, and even in an educational environment. We're going to be using it primarily for developmental work on our new project here. Now I'll show you a picture of that momentarily, and then we'll run through the schematic and show you the design philosophy behind it. Now, we wanted a couple of things. Number one, we want to be able to change out the components without the use of tools. Two, we wanted reliable, noise-free connections. Three, we wanted reverse polarity protection. And four, one of my favorites, is we wanted a split voltage supply. Some people like split supplies. Some people like a single-ended supply. I like split supplies. That's me. Anyway, show you the picture of it. We'll run through that, run through the schematic diagram, give you an idea how it works and how it has worked. Up with is this printed circuit board. It's about 100 millimeters by 110 millimeters. We'll run through it very quickly, then go through the schematic and get some of the details. Now, first of all, this board is limited to testing op amps that have the pinout of either the TL074, which is an extremely popular op amp, or the pinout of a TL072, another popular op amp. Now, you're not limited to testing the 74, and you're not limited to testing the 72. But the op amp that you're testing has to have the same pinout as either the 74 or the 72. Now, as you all know, the 74 has 4 amplifiers on it, A, B, C, and D. This is designed to test all 4 amplifiers. You test them usually individually. They can be isolated from one another to avoid interaction. We'll go through that momentarily. But let's run through the board here. Look at some of these components here. Where you see these black devices, they're nothing more than connection points. In other words, you put jumpers in there, you put resistors, capacitors in there as necessary. So you can have a inverted circuit, non-inverted circuit. You can put, as I say, various components in there to see how they'll react with your circuit. Now, some ground rules here. Wherever you see a star, like there's a couple of stars right there. Wherever you see a star, that indicates that connection is grounded. Wherever you see a bar like that, bar up here, bar there, that indicates that connection is connected to that connection. In other words, you have a connection right there. Now, in this case, these two are connected together, and these two are connected together. In other words, all 4 of these connections are connected together, but they are not connected to each other. In other words, these 4 are not connected to those 4. Now, we'll show you why we have it that way in a few seconds here. Your input from your function generator comes in here to TB2. This would be your ground or your common from your audio generator, your function generator. If you wanted to test a non-inverted configuration, you would put the input from your function generator here. That runs over to here through the tracks on the other side of the printed circuit board. Now, normally for a simple non-inverted circuit, you would just connect a jumper from here to here. As you'll note, these connections here are not connected to here, so you put a jumper in there. Very simple inverted, or rather non-inverted configuration. Now let's take a look at, say, amplifier A. Let's say we're working with amplifier A. They're all the same. Amplifier A is wired the same way as B, C, and D. You would put your feedback components in there. I say components. Normally you would just have a resistor. You may have an RC circuit. You may have something else plugged in there. In any event, you could connect 4 components in here that will be isolated from anything that's on this side. Notice these bars here. These 4 connection points are not connected to these points, as you can see by the gap there. Now going a little bit further, we have various outputs. For example, if you're working with amplifier A, you would take your output here. Again, we have 2 ground points, and we have 2 output, 2 hot points. You would have your output coming there. You may have a scope, a spec A, an audio meter on the other. Or, alternately, you could take the output from one amplifier and put it to the input of another amplifier. So you could have 2 amplifiers here. Now, normally, you probably would be working with 1 amplifier at a time. And you would not want to have all the amplifiers in the circuit at the same time. So what you would do is pull out the jumpers that go into these disconnect points here. By the same token, if you have the output from one amplifier going into the input of another amplifier, you would put jumpers in there as necessary, as needed. Going a little bit further down here, let's take a look at the, I don't call it the power supply because this does require an external power supply. But let's just call it the power unit. Your voltage, your power supply goes in there. You have an on and off switch, a couple of reverse polarity diodes for protection there. Here we have a little bit of a filtering circuit, some capacitors. In case you are using a switching power supply, which we do not recommend, we do recommend the linear supply. But if you do have a switcher and there's a little dirt in it, hopefully these capacitors here will clean up some of the dirt. What we have here is a simple rail splitter. Now, I don't want to get into a religious argument over this, but when I design op-amp circuits, I prefer using a split supply as opposed to a single-ended supply. In other words, say you have a 30 volts coming in. With this rail splitter, you'd have plus 15, minus 15. That's my own preference. I've found it easier to design circuits that way. I found them to be a little bit more stable. Your mileage may differ, of course. So that is the basics of our printed circuit board here. If you need some heavy ground connections, you could put them right there. I'm not sure if you would need them or not. If you need them, they are there. That's more heavy duty than these connections up here. I might add in passing, the weak point of any circuit like this, that has a lot of connection points, is the connections. Now, we bought some of these connections off, let's just say we got them online, and they worked fine for maybe, 15 or 20 connections. Then they start getting a little intermittent. So we got these connections from DigiKey. That's a highly reputable outfit. We got these connections. They are not cheap. They're very expensive compared to the ones you can buy online. But they're very reliable. They're gold-plated. They make good, solid connections. After many, many uses, we have yet to have one that would fail or get noisy on us. All right, let's take a look at the schematic. Okay, here's the schematic of our board. As mentioned previously, and as you all know, a TL074 or an op-amp with a TL074, in all probability is going to have 4 amplifiers on it, A, B, C, and D. Each amplifier has its own network, as we call it, or connection point, if you will, for connecting your feedback resistors, or you may have, say, an RC circuit in there in the feedback circuit for whatever reason. Usually, you're just going to be working with one amplifier at a time, in which case we have these disconnects. That totally isolates the amplifiers that are not being used. By the same token, you could feed the output of one amplifier into the input of another amplifier and adjust these disconnects accordingly. As we showed before, we have the input from the function generator here, ground. We have non-inverted input. We have 2 connection points. Inverted input, 2 connection points. Non-inverted, Usually you'll have a resistor across there. You may have an RC network. You may have something else in there. Anyway, each side has 4 connection points. Again, I have to stress, these 4 are not connected to these 4. So these 2 are isolated. If for some reason you have to have that connected to that with no resistors, no capacitors, you just simply put a jumper in there. No problem. Same thing down here. Now, for a very simple circuit, for non-inverted, a simple circuit, you'd probably just put a jumper between here and here. On the other hand, you may want to put a capacitor in there. Maybe you want some DC isolation. The outputs are over here. You have 2 grounds and 2 hot outputs for each amplifier. That can be connected to, if you're testing something, it probably goes to a scope or a spec A. Or the output can be fed back into another amplifier and the output taken down here, for example. It depends on how you configure this. It's very flexible. We tried to make it as flexible as possible without it being overly confusing. Now that's why we have that silk screen showing all these interconnects and where the grounds are, so you don't have to constantly refer to a schematic diagram to see what you're doing. Down here we have the power input unit, input on-off switch, reverse polarity protection diodes, some filtering for a switcher, and the rail splitter right here. All right, there you have it. I hope you found this little video enjoyable and useful. I know we've had a lot of fun designing and making this project, and we found it to be enormously useful, especially for developmental and experimental work, and also for checking out the op amps for the usual THD, frequency response, so on and so forth, slew rate, whatever. And if you want more information, take a run up to our website, boatanchoraudio.com. There's some items up there you can download, such as schematics and other items. Anyway, have a nice day, and keep those electrons flowing. Talk to you later.